Web 3.0, aren't we? We're supposedly there already. Aren't you Web 6.0 or something? It's like
roll one, take one.
I'm Gabriel, Rene, CEO of VRSSSF.
I'm George Gilder. I'm run 4 newsletters and writing books. Life After Capitalism, Life After Google, Life After AI.
Wonderful. It's so nice to be able to sit here with you today, George. Appreciate the opportunity.
Well, great to meet you guys. And you'd say you're doing Web 3.0. I thought we were already in Web 3.0. What's the matter with our existing ubiquitous web around the world? Being disrupted by nations everywhere, but still persisting and extending our sensory lives and visions and virtual worlds.
Well, I think, originally the term Web 3.0 had come from Tim Berners-Lee in the kind of early 2000s around this idea of the semantic web, right? Which was the idea that we would have the text-based version of the web where, for instance, the word greenhouse would refer to a specific thing and you'd know whether it meant a house that was green or whether it has a house with plants in it. That the meaning of words and references like George on a page could be sort of embedded. And this is where all this graph databases and graph technologies that started to kind of connect the relationships between words and their meanings really started. And there were technologies that were trying to really drive this third version of the web. But really what happened was search dominated so intensely that the need to have meaning embedded into every part of the web was a cost no one wanted to take. So I think Web 3.0 was sort of an ambition deferred. What ended up happening, perhaps thwarted. Then I think if we fast forward and we start to see what happened towards the end of Web 2.0, which was really a shift to mobile, and then GPS and location-based stuff, and we start getting into spatial, well, I think like Web 2.5 almost. And then you start to get, augmented reality, virtual reality. Oculus is purchased by Facebook. AI, deep learning really starts to break out in 2012 or so with AlphaGo. And then you have, blockchains, cryptocurrencies, and of course, Internet of Things, which is its own sort of internet, and robotics. And so the argument that we make is that Web 3.0 is really when the web moves into the world, and the semantics that they wanted to put on the web needed to be embedded onto the objects, the people, places, and things in the environment. So that really ended up being about the convergence of all of these exponential technologies, which then we started to describe as the spatial web, meaning the web that moves into the spaces around us.
So you're topological.
Yeah.
What are your next steps? I mean, I go out into the world and nobody's talking about VRSSSF except my moonshots editor, John Schroeder. He's been talking about you for years. But I also go out and there are 100 new schemes for the next web out there. And you seem to have made real substantive breakthroughs in establishing actual protocols that can enable the Web 3.0. Why don't you tell me how is this next web going to be reified?
So I think, interestingly enough, when we talk about planet scale computing, which is when you talk about something like the web, you're talking planet scale computing. This is very much about steak and not sizzle. And what I mean to say is this is about infrastructure development. If you don't get the infrastructure development right, the rest of it doesn't work. And infrastructure work is largely underground, quiet, right? All the plumbing and all the electricity, like that gets done in a way, you got to lay out the plan for the city before you really start the building. And so what we recognized very early on when we started the company was that you needed some sort of modeling technology that would enable AIs that are working through sensory inputs, right? Like the Internet of Things, cameras and microphones and robotics. So AI kind of having this embodiment in the physical world, and then humans suddenly being able to put something like augmented or virtual reality glasses, which Apple and others have clearly bet on as the new computing interface, that are looking at the digital world. And then how do you synthesize those two if both humans and AI agents are going to be operating in both virtual and physical environments? And that means that the world that you need to model has to be coherent. It has to be human and machine friendly. So we recognize that just like the web had hypertext markup language, a standardized format for every web page, we would need the same thing for every space, real or virtual spaces. So we started developing this underlying protocol, which we call HSML, hyperspatial markup language, modeling language, and we started working with the IEEE, who's one of the largest standards bodies in the world, which which standardized Wi-Fi and Bluetooth and Ethernet.
I mean, it is the largest standard body in the world, right?
And so now the spatial web standards are teed up to basically version 1 approval later this year. In fact, I think even this month we're submitting what will be the final draft of the first version for approval, which will take a quarter or so. Once that is the case, what of course but our folks listening probably don't know, is that standards are the quiet infrastructure that everything else runs on. So that's why manufacturer can make a lamp or a hairdryer or a TV screen and plug it into the wall and it all works. We want the same type of underlying interoperability layer for IoT, for robotics, for AI, for all of these different emerging technologies, so that the convergence of them is something that we can control in one level. So the standards come with a lot of abilities to define governance and policies and rules and laws over data and over the actions that AIs take in the physical world, but also to be able to guide these things in the directions that we want them to go and allow them, importantly, to be autonomous. We want AI to be able to do things without humans in the loop. That's the whole point of the benefits of their optimization. But we need to be able to make sure that the guardrails are there. So we've laid out that whole infrastructure layer, and then we started building the Genius platform, the VRSSS platform.
Well, tell me about VRSSS. What are you accomplishing out there with a whole new spatial web?
Well, VRSSS is what we call a cognitive computing company. By this, I mean, we're not focused on merely making artificial intelligence as a sort of one machine, but processing the cognitive processes of the mind, applying those to computing in an architecture that is more like a web of agents as opposed to a single sort of computer.
Yeah, you aren't building a singularity, you're building a multiplicity of avenues for human expression and control.
That's
over the
amazingly put. I was just thinking recently, I was talking to some folks from Singularity University, Ray Kurzweil, the famous futurist who coined the term.
Ray is an old pal of mine.
Yeah, so I was chatting with some folks last week, and I was actually making this exact point, which is amazing to hear you say it, that we can see beyond the singularity. There won't be a singularity. There'll be this sort of multiplicity, and so it's amazing to hear you say that. And and this is a scene we've seen before, George, right? Where everyone thought building the one big thing was the way to go, but it turned out building lots of little things you could connect.
That's what I've said from the beginning. I mean, I've just come back from a conference in Panama of Singularity.net, which has the AIX.
Right. Ben Goertzel and those folks.
Yeah, Ben Goertzel was running the conference.
Yeah.
And I met David Brin, who's the science fiction author of Earth, which kind of envisages a whole Gaian model of the universe. Anyway, but the question is whether this whole idea of AI as a monolith or as a singularity or as a one thing, as if thought is unitary rather than multiple and phantasmagorical and so this whole idea of the singularity, which I love Ray. He's a terrific genius.
Yeah.
But I don't think we want a singularity.
No, I don't think so.
We know that thoughts are ubiquitous and multiple and
diverse.
And certainly diverse.
Yeah.
And and reality is diverse. It's not single faceted.
Right. Or based on just data from the past. The reality keeps changing.
Yeah, it's constantly it's dynamic. That's another thing. This whole idea that you got some thinking process that's based on previously collected data, which is not really weighed for its accuracy or truth. And that's why one of the things that appeals to me about verses is your understanding of the need of a truth layer.
So you said so many amazing things there. The first one that I noticed was the idea that most of the competition believes that the foundation, the kind of operating system layer for AI, is to build a single monolithic system that collects data from the past, picks the top answers, and then doesn't learn anything beyond that. And then you kind of search within this sort of monolithic AI that's really only knows what happened before.
It's a cloud.
Yeah, it's very much like that. It's a very industrial mindset, actually, right? And so what Versus is doing is we're applying active inference, which comes out of neuroscience and comes out of sort of biophysics, which really looks at how do natural intelligence work.
Active inference, this is the core of Versus. Tell me about active inference.
Yeah, so active inference comes out of the work of Professor Carl Friston, who's one of the top neuroscientists in the world, most cited neuroscientist in history, I believe. Professor Friston invented statistical parametric modeling, which led to fMRI. So most of what we know about the brains today can be attributed to essentially the mathematical modeling of Professor Friston. He joined Versus a couple years ago as our chief scientist, and we've hired most of his colleagues and former PhD students because what Friston figured out was a completely different, alternative approach based on what we understood how the mind and how cognitive systems and biological intelligence processes information.
And what is that? What is Friston's insight?
So it's in the name active inference. So instead of merely trying to know everything, you're inferring things. You're not trying to know everything from the past. You're trying to actively infer. What does that mean? It means I have to, in order for any system, living system, let's say, to be able to effectively act in its environment, it needs to model its environment inside of itself. So you and I have a model of this room or of Los Angeles. You've got a model of your kitchen in your brain. So you're able to build a model that is a spatial or physically coherent representation of the environment that you need to operate in. Otherwise, there's no hope of you catching the rabbit or getting away from the lion, right? And so the same thing happens for all biological systems. Because of this understanding, it appears that evolution, or nature itself, has designed intelligence to be able to adapt to new information, to be able to have essentially a simulation of what you think your future states should be. So you're instead of trying to predict from the past alone, you're trying to predict what you think you might do next, given a set of options. Yeah, and so because of this, there's actually a mathematics of this, which is the mathematics of probabilistic predictive algorithms. And so active inference is a probabilistic, meaning weighing essentially several possible outcomes and then trying to predict the right one. Instead of trying to take all the data and just pick the top answer from the patterns, it's trying to figure out the right data. And the result is you get AI that can adapt to new information, that's extremely light and efficient, and therefore it can operate on small devices like Internet of Things sensors, robots, cars, drones. And most importantly, it can adapt to changing environments and situations. So it can self-tune that multiplicity that you said before into each different environment. The same way that intelligence is different in a jellyfish or a squirrel or an ant colony than it is for you and I. That multiplicity of intelligence is now enabled, but now in a digital substrate, and now in a network architecture, and that becomes essentially the spatial web that we talked about.
We're flooded with speculations and apocalyptic visions of AI as we already have it in ChatGPT, given the most probable token based on the history. Right. How does active inference radically change this perspective? How does it accommodate human creativity, for example, which always comes as a surprise to us? Yeah. As a matter of fact, the more surprising, the more potentially valuable it is. And so all averages of the sort that are supplied by a model like ChatGPT really purposefully miss the most valuable insight or the most valuable path. What does Versus do and active inference do that breaks out of this somewhat sclerotic AI model that is sweeping through the world by injecting random numbers? It imagines that human creativity is a random number generator. And we are not random number generators. We're active inferencers, and we're constantly creative. And there are 8 billion of us, and we're not a singularity. So Versus accommodates this world of human beings as they are, rather than tries to substitute some singularity for the actual human mind and all its multiplicity.
Wow. You said all my favorite words there. That was
all right.
amazing.
Well, I'm trying.
I think several thoughts there. So the first one is, what Versus is trying to do is enable intelligent agents that are smarter, safer, and more sustainable. They're smarter because of their ability to adapt to new information. And so you talk about, evolution and emergence happens at the edge. So any homogenized system that's trying to pick the most popular answers from the past is not going to really drive that. Secondly,
evolution happens at the edge.
Evolution happens at the edge, right? And so importantly, what you need is a system that can be at the edge in all the different dynamic environments that might occur, not in a data center in Silicon Valley, but on the devices that you're operating.
Or in Iceland, worse.
Yeah, perhaps, yeah.
Or up the Columbia River without a paddle.
Exactly, which is where it feels like we might be going with the current approach. And I think the other important thing is this idea of extension. So tools essentially act as extensions of human capability, of human creativity. And it's because when we reach the limits of our own strengths and capabilities, we've always invented tools to extend our physical bodies, right? Catch the animal with the spear, our senses, right? Our vision, even our memories in the form of writing or books, or even the World Wide Web, or even ChatGPT, I would argue, is just more memory, more knowledge. But today's problems are not solved by homogenized average, which is kind of an industrial mindset. Let's make the one-size-fits-all thing. And what we really want is personalized medicine, personalized education, personalized entertainment. And these are things that can only come from a system that understands you, with your data, understands your patterns, right? Which gives you the control, not just a giant sort of system in the cloud.
It's got to jump the uncanny valley, or it can be constantly interfering in an offensive way.
That's right, and so it's really important that it understands where we're coming from. I mean, and so you have to then have the ability to have an agent that can learn the way that we learn. It cannot just be this sort of average, homogenized, one-size-fits-all. That I would argue that that's a machine, and that the machine age began with machines printing and ends with machine learning. And what we're talking about with active inference agents is something new.
Well, that's great. I love that line. The machine age began with machine production and ends with machine learning. And now we have to move. Transcend the machine.
That's right.
Now, transcend the machine mind. But to do this, we're going to have some kind of physical embodiment of these systems that you're describing so eloquently. So what you got a number of paths. You got a protocol path, new industry standards, new infrastructure. What if I want to build a company that builds on the new versus web?
Yeah.
What do you do? What are you giving me that enables me to do something miraculous and fruitful?
So we're building a platform for developers called Genius, which is genius being beyond smart. We talk about smartphones, smart cars, smart cities. We want to make things beyond smart, things that continue to get smarter, so the genius of nature sort of infused into technology. This is very similar to the kind of operating system for mobile, for smartphone development that Apple enabled in 2007 that has allowed tens of millions of developers to use the software developer tools that Apple enabled to build and run things on their operating system. So we've often talked about Genius as a type of agent or AI-based operating system. And you'll remember this point very well, but in 2006, Nokia was selling 1 billion phones a year. Everyone had a BlackBerry or a Motorola or a Nokia in their pocket, right?
Who made BlackBerry? I forgot.
RIM.
Yeah.
Great Canadian company.
Yeah.
But Apple figured out something that the rest didn't figure out, and I would argue that this is what Versus has figured out. And today's AI companies are the Nokias, the BlackBerries, and the Motorola's of this age. Here's what they figured out. Linux was an open source, operating system.
Yeah.
And just like the spatial web protocols we design today are open standards. But Apple said, what you really need is not just to add web pages onto little tiny phones. You need to build a computer that's the size of a phone, that has a new kind of mobile operating system, and then you add the phone as an app. You flip the entire model, right? And so that's what we're doing here. No big data, no giant compute architecture. You don't need 40,000 NVIDIA computers to run these things. And just like that, I think something you stated, going from the mainframe to the microchip is sort of like Versus is more like that Intel inside, right? Instead of IBM, that's going to be able to be put in every device where AIs can actually operate at the edge. What does that mean? A much larger total addressable market and way more significant value, because that value then gets fine-tuned to the devices and the environments and the users that it needs to work with.
8 billion users.
Well, 8 billion human users, but we're talking 100 billion IoT devices.
IoT, all right.
Yeah.
When we got an AI versus phone, what will we be able to do that we can't do now? Where will it be? Will it be in our ear or in our, what is this new world that you want to launch for us?
Well, I heard two questions there. So the first question I think is, how does this scale, right? And so let me make sure I articulate that. When iPhone came out, it had 12 apps on it. And Steve Jobs was opposed to the idea of developing an app store. Yeah. And a couple folks internally said, look, this is how we really scale this thing. We don't want to build all the apps, right? If you let everyone else build the apps, the multiplicity of applications and the diversity of the applications will find users. Yeah. So the phone was just the sort of delivery agent for apps, and that's really all it is today, right? Yeah. It's a bit of hardware upon which all these applications are able to run. With Versus, there is no hardware. So we're going one step further. We're not even going to make the hardware, and we're not going to make the applications. We're going to make the operating system, but the operating system is essentially virtual operating system. This allows developers then to deploy any type of agent-based application, which they will develop and run on our infrastructure, into any device, a camera, a phone, a car, a robot, right? And so because of this, we're actually going one step further. People might look at this and say, well, Well, at least Apple had a piece of hardware they could a distribution channel through which they could push this. I would argue we have a much better distribution channel. 100 billion IoT devices, robots, drones, cars, and the rest. And so we don't even have to incur the cost of physically manufacturing anything. We're just essentially enabling intelligence as a service upon which we expect millions and millions of these agent applications. Now, what would that look like in a practical sense, right? Today, when Tesla or Volvo or BMW tries to make an autonomous vehicle, we all just saw Apple shut down their autonomous vehicle group last week after 10 years of investment, right? Yeah. And the reason is that the software that's running these things is not sufficient enough to get the kind of past the regulations we need to have level 5 autonomous vehicles. Because, as you know, they're only training on historical data, and inevitably you're going to encounter some situation driving that you've never been in before, and they can adapt. With Genius, with our agents, Volvo could develop an autonomous vehicle agent that learns to drive in a scenario it's never been in. So let's say it's Detroit, and next winter, let's say it's historically there's data that it trained on that says 2 inches of black ice it knows how to brake on. But next year, it's 3 inches of black ice, right? And it's never learned how to do that. Now, through some experimentation, it figures out how to do some sort of stutter step thing with the ABS braking. Well, now it's learned to do something that it's never done before through some experimentation. You could obviously do this in simulation environments and reduce the risk of a physical environment. But then our agent can take what it's learned and pass that to every other Volvo car. Yeah. So you get compounded network effects, what I call hyper-intelligence, right? And you can't do that with any AIs today. Now, today I've got a Ring camera, or you might have a Nest camera at your house, or a Nest thermostat, right? My Nest thermostat is supposed to learn, it has some AI in it, what the average temperature is and kind of the range in the house. But it doesn't really know who's in the house. My wife has a different temperature preference than I do. But it would be great if the cameras in the house did know who was in the house. Oh, grandma's in the house, let's warm it up 2 degrees, right? Or we're having guests over, let's cool it down 3 degrees. But it doesn't know that because you can't connect these 2 different AIs to talk to each other. With the spatial web and Versus now you can.
But Jeffrey Hinton is talking about all the time the great virtue of AI is it can render ubiquitous these insights that a singular AI discovers, or that software can be infused in all the AIs around the world. But that's the singularity model. You got a multiplicity model.
Unfortunately, Mr. Hinton is taking a faith-based perspective on what should be science. And this is not just me saying this. His former Turing Award and colleague, Jan LeCun, who Carl Friss and our chief scientist recently debated in Davos a couple months ago, has openly disagreed with Hinton, right? And said, you're misunderstanding the technology that you invented, and you're basically, and you point this out, people are either seeing angels or ghosts, right? In these, but what's really happening? Google comes out with Google Gemini after a year to compete with GPT-4, and it's 1%, 2% better. Last week, Anthropic came out with Claude, and it's 1%, 2% better, and a couple.
Maybe worse.
Maybe worse in some areas. Yeah. And it's because the big reality that they're not willing to face is that they can't get any better than the data, because that's all it learns on. Our agents don't just learn on data. They're learning by forming beliefs about what they think the data is good for. And then they're able to adjust their beliefs because they're able to simulate future states, right? And because of this, they can continue to learn. Once they learn, they can share with others. You don't need to learn from scratch or try to understand all of the universe. And even if you did, imagine if you took the first 10 years of your life and you trained one of these AIs on it. How likely is that AI to work well for the next 10 years of your life? Right. So it's the wrong architecture. If in a world filled with uncertainty and change, where every business needs to adapt to an ever-changing business environment, you need algorithms that know how to adapt as well.
And you need to have them anchored in a blockchain so that you have a truth layer, a layer where the fixed realities of your environment are registered immutably.
I have long been a fan of blockchain technologies. What we realized as we started to try to figure out how to implement this in something like a spatial web architecture was that the limitations of blockchain render it extremely limited in its applicability. So what we did with the spatial web standards is we took some of the core functions of what blockchain does, the ability to have trust in your data, the ability to be able to look back and see where the source of that data, sort of data supply chains, data lineage, the ability to set rules and permissions or contracts over that data or over the actions that robots or drones might take in the world, without the need to register it on a blockchain, without the need to have a global perspective. So one argument that I have is that blockchains suffer from the same global problem that LLMs have. The blockchain itself, or a blockchain, any one blockchain, is trying to say that all of the computers have one perspective on the data, and they all agree, and that's your algorithm, right? And you have an incentive mechanism to do that. But let me ask you what you would prefer. I have the Hope Diamond in this room, right? And now you can either have the Ethereum blockchain register that somehow somebody believes that the Hope Diamond is still in the room, and now you've got a million verified computers around the world that say that. Or would you prefer 10 IoT devices in this room, all from different manufacturers, depth sensing, multiple cameras, weight? I would rather have that local consensus rather than a global consensus. However, the two together is better. So if I've got local consensus,
both,
and then I can back that up on the blockchain. Now the blockchain is a great record of the truth, but my source of truth comes from some local data set that is
correct,
right? And then I see them being a virtuous cycle there, where we're not relying on the blockchain to be the oracle under which we tell what happened, but rather being an immutable record, and that I think is very useful.
Well, I think you're a moonshot. That is, you have an original vision that projects beyond all the noise of competitive companies. There's, I don't know, I didn't invent it, but there's this idea of the red ocean strategy versus the blue ocean strategy. The red ocean is red because there's blood from all the competition and various zero-sum game conflicts. And while the blue ocean transcends the red ocean, and it's the horizon of the future, and that's where we project our moonshots. And my newsletter, Moonshots, with John Schroeder, who introduced me to you guys and is a great exponent of versus as the next moonshot. And so it's, and I think it is the next moonshot, because if your notion of intelligence is a singularity, that's a zero-sum game. Everybody's trying to control this singular intelligence, and you get this ludicrous business of DEI or DIE at Gemini, and even two can't live together in one system. So we want hyper-intelligence, intelligence that's distributed, that is distributed as widely as human minds to 8 billion, but also its sensory apparatus is as broad as the Internet of Things, of hundreds of billions of potential items, yet all somehow anchored in, if not precisely a blockchain model, a model that immutably records truth so that any random hacker can't disrupt any particular item in this vast web of 3.0 web, that you're providing the protocols, animating from the drones above to avatars within, and it's you've made a deal. Maybe we should end with this deal you made with the European Union about controlling drones. Drones are 3D items that can cause all kinds of mischief and destruction unless they're somehow registered and channeled in 3 dimensions. And how would you do that?
Well, I think one of the things everyone gets wrong about the concept of artificial intelligence is that the main benefit of AI or intelligent agents like the ones we're producing is their ability to function autonomously. What we want from them is to basically do things that we don't have to do. Do them better than us and do them more intelligently. Now, what you don't want is something that is autonomous but stupider. Right? If it's not smarter, then whatever it's doing, I mean, could cause harm instead of health or wellness. And so what's critically important is you want to have a wide berth for any autonomous thing, especially if it's one that can learn, self-improve, and adapt, because all of the benefits of that edge of evolution will only occur if you kind of let the reins go a bit. But it's really important that we can set up the guardrails and the boundaries for what degree of autonomy can occur, number one. Number two, based on, and the ability to be able to tell what degree of intelligence is this agent able to basically deploy in this environment. The smarter it gets, the safer it is. The smarter it gets, the more autonomy we can give it. So how do we know this? We've been testing this with the European Commission for the last 3 years. Drones, essentially AI-powered drones in 5 different countries and 5 different cities across Europe, where we could define the constraints. You can fly here, you can land here, you can film these people, you can't film these people, right? And all of the sorts of physical constraints, conditions, and boundaries, which, like blockchain, uses something like a smart contract, meaning here's what you can do and here's what you can't do. Then every action that these autonomous agents take on our system has the ability to have some legal or ethical or other constraints. That, to your point about Google, is not a monolithic ethical perspective, but rather can be specific to any one user or application, which is the only way that you can see things being fit for purpose, is that they're evolutionarily fit, or the applicability in the environment that they're operating. So you don't want this monolithic laws in AI. You don't want monolithic governance. You don't want monolithic ethics. You want this multiplicity, you want this diversity to be baked into the capabilities of the system. Then you get the benefits of something that can perform these autonomous actions, but also can do them in ways that are, law-abiding
within the guardrails.
Within whatever the boundaries of the guardrails. So that's really critical. I have a question for you, George. What do you see, if we kind of look out beyond where most of the folks are talking about, which is a monolithic AI, gets scaled up with all these chips and all this hardware and all this energy in these data centers to become what we call artificial general intelligence. This is the current narrative, and that somehow then it magically starts to self-improve to where it becomes super intelligent, and this is the singularity that has sort of been popularized. But if we look at this through the lens of natural systems, network systems, and in our case, what Versus would enable, which is many, many agents that can all share and learn and work together, like you and I are even learning and working together, and people listening to us today, we actually are collectively intelligent. And so where do you see beyond the singularity, beyond super intelligence, and what kind of world do you imagine seeing all this convergence of all these technologies, this Web 3.0, what does it enable, and what do you see the benefits of that system being?
Well, I see the current world as a repetition of the old IBM mainframe era. We're going to have 16 mainframes, 200 mainframes or something, and they were going to satisfy the world model for computation, the world market for computation. And now we have a few hundred giant data centers where supposedly the same database will be endlessly churned and yield a singular model of global intelligence. This is some new static Moloch of a god of intelligence that tech community is strangely bowing to. And I think Versus offers a moonshot and emancipation for this limited, restricted, singular AI into a polymorphic AI that will serve individual human minds and enhance them, rather than force individual human minds to somehow defer or succumb or bow down to this Moloch of supposed master intelligence. And so I think proliferate, let many flowers bloom, and you'll get away from the Maoist era of artificial intelligence into the Deng Xiaoping and then the versus global regime of emancipated intelligence.
So George, I wanted to kind of talk about the hardware layer of what's, the materials science breakthroughs, as well as the new kinds of chips that we think are going to be coming out, like neuromorphic chips and others that are going to break out of the old sort of computational paradigms and allow for, 10,000 times, 100,000 times, more efficient compute.
Yeah.
So,
well, this is what my new book is about. It's called The Graphene Moment. And graphene is counterintuitively moving to simpler material forms. It's a single layer of carbon atoms that's 200 times stronger than steel, that's 1,000 times more conductive than copper, that is the most thermally robust material ever studied by scientists, that's yielded a whole new science called topology that's won 6 Nobel Prizes, that actually defines how much you can change an environment without affecting its essential functionality. And so there's, graphene is, in the last few months, in January, they created, Walter de Heer at Georgia Tech and some of his students in China, of all things, created this layer of graphene on silicon carbide that can make possible overcoming the restrictions of chips. When you think of the existing electronics industry building these giant boules of silicon and then slicing them into layers of wafers, and then inscribing trillions of transistors on this wafer, and then dicing the wafer into thousands of chips, then sending the chips off to Malacca or somewhere deep in the Pacific where they get transformed into packages, and then they get reassembled on printed circuit boards. I mean, it's a crazy quilt of manufacturing inefficiencies when you really think of it. Graphene allows wafer scale integration, many fewer wires, no heat buildup. All of the data centers, these IBM supercomputers of the past, recurring as giant data centers next to glaciers.
Right.
And these, all these technologies can be reduced to wafer scale devices that can, that don't need wires, because the graphene transmits electrical charge ballistically, rather than when you send electricity down a copper wire, it's bouncing all around and bumping into all the features and the other
Right.
electrons,
getting all the extra
and
heat.
it's really very slow.
Yeah.
But 2D graphene sheets gain ballistic, ultra-relativistic, Dirac fermions, the electrons become, that communicate much faster and more effective. And so there's a whole new breakthrough in material sciences. That moonshot is converging with your moonshot,
Yes.
and together it's going to be a real outer spatial exploratory convergence.
How thrilling. I mean, it's another example where superior science trumps engineering, right?
Yeah.
Like, you have to do good engineering, but if the science is right, this material is simply more conductive, right? Then all of a sudden it just leapfrogs the previous history. And I think this is the thing about innovation that you've written about, is innovation doesn't happen in this sort of smooth curve. There's these jumps that seem to kind of come out of nowhere.
Paradigm shifts.
Right. And so whether that's in material science, or whether that's in network architectures, or whether that's in algorithms, the black swans show up, and then all of a sudden these are the moonshots you talked about. One thing that I think this is reminiscent of is that what we call neuromorphic hardware, right? So neuromorphic chips, which are just sort of starting to come out now, are essentially allow for something much more like the way that the brain processes. So a neuron is both storage and processing at the same time.
Yeah, right.
But what we have today is essentially what's called the von Neumann architecture. It's
Right.
one of the founders of modern day computing, is that the processors on one side and and storage is on the other side. So it's got to run back and forth. It's a bit like putting the forks on one side of the house and the knives on the other side of the house. And every time you got to serve dinner, you got to run. So that causes all that extra heat. That's obviously extra cost. And what you want is the ability to have the processing and the storage happen in the same place.
And that's what graphene enables.
Exactly. So once you enable that kind of capability with what we've been able to do, which is active inference, even at neuromorphic chip layer, you're talking about, 100,000, X performance here. And so what people I think have difficult seeing is that it isn't this smooth curve. There are these paradigm shifts that occur. And then when convergence
Some people call them singularities.
Singularities,
But they're multiple.
There are multiple singularities. And when you have these convergence of multiple different exponentially powerful technologies, I feel like that is the age that we're standing on today.
And that's what Ray Kurzweil, who really concocted the singularity notion, is actually projecting beyond it into this kind of world that Versus is envisaging.
Yeah. Well, and which we're this year we'll be rolling out all the tools to help build. So
okay. I hope Versus becomes the dominant form of what they call artificial intelligence, but really takes the artificial out of intelligence. I mean, this is the whole idea that we're creating some artificial world that's somehow going to dominate our human world is a misconception from the beginning. And you guys are transcending this in a moonshot that'll create a real world that is worthy for human beings to live in.
Yeah, we want to enhance and extend human capabilities. We don't want to build one giant smart thing that everyone has to tether to. We want to make people, places, and things smarter so that we all get smarter together, can tackle all the various challenges and problems we face today, but are also set up well so that future generations can continue to, evolve these tools and the human race in a much better direction than I think has been laid out today.
Hear, hear.
George, thank you.
Thank you so much.